Hello, welcome back to China Manufacturing Decoded from the Sofeast Group, episode 205 today. And Paul Adams is joining me this time. This is Adrian hosting, and we are going to discuss something that we do need an engineer on the podcast to discuss, and that is development prototypes, right? And what you're going to do, Paul, hopefully for us, is you're going to go into what development prototypes are. We can cover that briefly, and also the issues and limitations of these, right? So, first of all, welcome.
Well, thank you, sir. Good to be back again.
Absolutely. If we get started with a bit of context then, and a brief introduction into what am I talking about when I'm talking about development prototypes. I mean, it's certainly not mass-produced products, right?
No, that's right. And now when we're talking about prototypes, I want to break this down into two things as we move forward. Generally, when we're talking about prototypes, people think about 3D printed plastic components. Okay, so which is a very valid point. And we're going to cover that. But we've also got metal prototypes. So if we've got a production unit that needs to be have a cast product or a casing or a gearbox, for example, how do we go forward with respect to getting a prototype up and running for development purposes? So I'm going to break this down into two sections. First of all, I want to cover the plastic side of things, and then we can touch on the metal side of things and how we can actually approach those two particular materials.
Yeah, that's very true. I mean, look, you go into most facilities these days that are doing prototyping, and you're likely to see CNC machines, for example, right? And so, what are they doing? Well, they're working with metal, and there's a reason for that. So, yeah, it's good that we're going to cover the metal as well, for sure.
Let's take a step back and look at sort of why are we producing a prototype to start with during the development stage. Now, there's three things that normally come to mind. It's fit, form, and function is what we normally use, and that term is thrown around a lot in the development stages of getting a prototype up and running. Now, the fit, form, and function is obviously there for a reason. Is the product fit for purpose? And that's the first style of prototype. And this can be rough and ready. And this could be literally not even plastic at all. It could be simply a couple of switches inside a cardboard box, for example. Very rudimentary. Does the system that I'm thinking about function? Is it okay? Is it fit for purpose? Is it fit for moving forward? Well, one would assume it is, so therefore we're going to be moving on to the form. And this is where we start to get the details of a product into your hand. So you've got your 3D CAD, you've gone through some designs, iterations, you've got your industrial design potentially at the first or second level. I think it's looking pretty good. Let's make a prototype to see what it looks like. Okay, so we know that it's fit for purpose and it moves forward. The form of this is really bringing the idea to life, and there are limitations to that. But then fit, form, and function, and then we're really looking at the user interface type of thing. And this is again, it's different prototypes are required for different purposes, and this is one of the things that we need to understand as engineers, and a lot of our customers need to understand as well with respect to the differences between each of the styles or the stages of the prototypes. Now, again, we're now looking at the different processes, and I'm going to stick with the plastics for the moment, and I'll touch on the metals later, Adrian, if that's all right. So if we're looking at the plastics, for example, we're looking at the pretty rough and ready DFM style, where you can get these like 3D printers that lay down a layer of filament at a time and build up a very rough layer of material to create your final product. Now, this is clearly not going to be very useful for marketing, for example, or putting in front of a client or a customer, or a potential customer or a sales tool. it's too rough, but it's serving a purpose. It's actually bringing the 3D CAD off of the computer and into your hand such you can have a look at it. But don't expect any miracles with respect to the surface finish or tight tolerances or anything like this. Even with post-process finishing, where we can start to sand things down and potentially machine surfaces or holes or things like this, it's not going to be your, top drawer, top quality product that, you can use as a sales model. It's just not going to do. So we've certainly got a limitation there. But if you do want to move on to something a little bit better, so high fidelity, for example, to use a term, we've got different processes nowadays. We've got SLA, and SLS, which is selective laser sintering, which do give a higher resolution. They give you a higher tolerance, or a tighter tolerance, let's say, right? And you're able to provide that post-process finishing such that you do get a reasonable surface. But again, you're not going to get that really, really high quality, high gloss finish that you would from an injection molded part out of a tool for production. Now, and again, it's setting the expectations with respect to which each of these processes can provide versus what the product is intended for. Now, I want to keep on bringing us back into these are development prototypes. In other words, we're still in the development phases of a product. We're not anywhere near production yet. So there's no tooling laid down for any injection molding tool at all. So, we really need to understand what some of these limitations are. So we need to look at the fit, form, and function, right, from a development aspect. Okay. So some of the things we need to consider, well, having said all that, right, we can now dive a little bit deeper, and tear back a few of the layers with respect to what does that mean, you're asking? Well, I'm talking about stability, so if you're looking at stability of a thin wall section, for example, if that wall section is relatively high, so 50, 60, 70 millimeters or a couple of inches, depending on where you're coming from, you need to make sure that you've actually designed that correctly. This is potentially going to be different from the production result. So your 3D printed product may warp, or it may bend, or it may come out of tolerance requirements in your prototype, whereas from a tooled component, right, it may be okay. So we need to look at that. Okay, so that's one consideration for sure. The other thing we need to be looking at is the thickness of layers that the prototype process can actually produce. Now, if we're looking at SLA and SLS, right, that's pretty small. So 0.1, 0.2 millimeters, which is, quite small. And that's pretty good. However, that's not as tight, or it's not as small as what you would expect from the production injection molded parts. So again, limitations on what we can expect from our 3D printed plastic components. And another one is high resolution, high finish. The process here is with SLA, stereolithography, which is a resin. That's it's a melted resin, so you can actually get a pretty good finish on that. But the material is not a gloss finish, so this is not going to be a gloss finish. You may apply a varnish or some other lacquer to actually seal it and provide a smooth surface, a gloss finish. However, you're adding thickness to that product by that finish. You can even add paint, spray paint, or just brush the paint on. But again, that is adding thickness. Adding thickness means you're coming out of tolerance from your original component. So again, this is a big limitation if you are expecting the fit of two components to act as if they were coming out of injection mold tools. Big things to remember
Mm.
and to consider. Another thing you've got to be looking at is snap fits and hooks. That in general production environments, some of the polymers that we're using are flexible and designed as a living hinge, polypropylene being a typical example there, but you're not necessarily going to get the same effect or same performance from a 3D printed plastic component. And consequently, when you're trying to
Mm.
determine whether two components snap fit together and will this be okay in production, well, guess what? It may break. It may break. Particularly over a period of time where you're trying it a few times, inevitably it's not as strong or it's not as flexible. It certainly doesn't have the same mechanical properties as the final polymer that will be used in injection molding. A lot of these are big considerations and limitations for the process itself.
Mm.
And again, I want to bring us back into, remember, we are in the development stages of putting a product into market.
Yeah, I was going to say this is, something to remember because I think maybe sometimes, and I'm sure you've had this from customers over the years, they see a prototype that's made during development and they're like, "Hey, hang on a minute, this is not up to standard. This isn't what my mass-produced product needs to look like." But of course, that's the whole point, isn't it? We're not trying to replicate the mass-produced product in terms of the exact look and finish necessarily. We're trying to make a prototype that's going to tell us something about how the product is functioning and help us to test and validate.
Yeah, I think you nailed it. It's exactly that. And the majority of people understand that, but there are exceptions. Obviously, there
Yeah.
are exceptions. And it's these exceptions that we need to manage the expectations of everybody involved, and don't get me wrong, we can work with our internal team. We can work with external suppliers when it comes to 3D printing, and make sure that we get the resolution as fine as possible. We get the print speed as slow
Mm.
as possible. That there are a number of characteristics within the process itself that can be fine tuned in order to get the best possible result from the process or each of the processes involved.
Mm.
And that takes time, obviously. And the post finishing, post process finishing manually by hand takes time, and time is obviously money. So what I'm saying is, you can get exactly the same prototype in the left hand. It's, produced within a couple of days and you've got the product in front of you and you think, okay, this is what it's going to look like. This is fine. I'm happy to move forward. Whereas the one that took 2 weeks
Mm.
and 3 times the cost is pretty much, this is a good looking product. I can take some photographs of this and, instead of my renders, I've got an actual product I can take photographs of. So
Yeah.
there are expectations, and there are still limitations on that. The right hand product where we spent a lot of time and a lot of money, but that's the trade off. That's the trade off. But in general,
Sure.
you need to be looking at, through the development phase, let's look at making sure we've got the fit, form, and function all ticked off, and we can do that through rapid prototyping and 3D printing.
Mm.
So that's your plastic. And one other thing I just want to bring to the table on this is size. Okay, I think everybody's been on YouTube or watched a video of the chess piece being made and some of these intricate components being 3D printed, and everyone's going, wow, look at that, that's really cool. And they're
Mm.
relatively small. And the smaller the component, the higher the accuracy. If, for example, some of the products that you may require prototyping may be like half a meter long or something like this. This is where we have potential limitations with respect to keeping that product within any type of tolerance, that is acceptable for the fit, form, and function testing moving forward. The larger the product,
Mm.
the bigger the problems you're going to have with respect to keeping that straight, keeping that in line, not warped. You're going to get all sorts of funny things happening with the larger products. All right. That there are ways around it. We got a lot of support structures within the process itself in order to produce that. But again, it takes a little bit longer, and there's a higher risk factor with respect to it's not going to be as accurate as anything that's going to come out of a tool.
Yeah, so we do need to know the limitations of plastics. I know you've outlined some of those really well when we're talking about prototyping for sure.
Yeah.
Okay. And so going back to the start, you did mention it's not only about plastic. We do sometimes create prototypes in metal.
We do. Yes, we do. Clearly, and a lot of people out there are thinking, well, I don't create any plastic. All my products are metal. It's like whether it be a gearbox or whether that be a component for a motorbike or an e-bike or whatever the case may be. And so a lot of these components are required to be produced from metal. And I can hear everyone saying, "Well, just CNC machine them." That's not a problem. Well, yeah, we can CNC machine them. That's not a problem. But again, there are limitations with respect to if it's going to be a high pressure die cast complex housing for a motor, for example.
Mm.
Can you get all of the undercuts? Can you get all of the cavities machined out correctly from a CNC machine? Maybe, maybe not. Again, we need to have a look at the limitations on that. Now, one quick way forward is to get your first prototype done via plastic. That's the obvious one. Just to make sure that it looks okay. Make sure that this is exactly what I'm thinking it's going to be. But clearly, you won't be able to do any functional testing of a gearbox with an intended plastic, intended metal part with any plastic parts. And that goes for gears, for example. So
it's a bit aesthetic.
Yeah, exactly. That's all it can be. That's all it can be. But again, we do have the technology available for us today to do a 3D metal printing. So it's very similar to the plastic process. We're looking at a 3D metal sintering, which is really good, and this can actually provide a pretty good replica, the same as what the plastics would, of the product itself. So, in my mind, I've got a gearbox housing. For lack of a better imagination, that's what I'm thinking of at the moment. So I know that a gearbox housing has, fairly complex contours around it. It's got some undercuts. It'll have some bearing holes. It'll have some mounting holes. It could have a logo etched in it or embossed in it. It's going to have all sorts of details on it. And with the 3D metal printing, you're able to achieve all of that. However, I must stress there are limitations with this metal as well. So if we look at some of the limitations, we're looking at the strength. Obviously, it's not going to have the same mechanical properties as your finished high pressure die casting product. It's just not. It's going to be okay for initial testing. Don't get me wrong. We'll be able to do some initial testing on that to validate the product, make sure everything's functional, make sure everything's working. But will it last the length of time? No, it probably won't. It's not meant to be. It's meant for, again, bring us back into the development phases of a product. It's meant for, making sure that we can validate the product before we move into any expensive tooling. Because if you jump into tooling without going through the validation of your prototypes and there's an issue, guess what? That's an expensive jump to make. Because you're potentially, forever chasing your tail on modifying the tools, or you got to scrap them and start again. And they're not cheap, Whereas,
we just mentioned this last week, actually.
Right? Yeah, it's very topical, and it's better to make iterative changes on a prototype, where you could print one, test it, make changes where you see fit, update the CAD, release the files and get another one printed out, and away you go. Now, if
Mm,
you are, if you're looking at a simple product, yeah, for sure, you can go CNC machining. But again, you're looking at the limitations of CNC machining versus a cast product or something like this. You got the setup cost. For a one-off component on a CNC machine it's not as cheap as a 3D printing process. You've got material limitations with respect to what you can use, and will it be the same as your high pressure die casting, for example? You've got to take that into consideration. A lot of the times, it's everything's a trade off, and everything's a compromise because there are always limitations on development prototypes, regardless of whether
mm,
it's plastic, whether it's metal, or any other sort of fabrication you can think of. There's always going to be a limitation at the prototype stage. And that's for a reason, because we're not actually spending the money in order to go into full production until we're validated and confirmed the design is ready to move into mass production. So
mm, mm.
all of these sort of materials, you need to look at the mechanical properties and say, okay, if I CNC machine it or if I 3D print it versus my final product material selection, how close am I? What are the limitations I've got to work within? And you need to base your testing through the development stage based upon that data and information you have at hand. That makes sense?
It certainly does. Yeah, absolutely. Okay. So we've set the scene on, well, kind of the difference between a prototype and a mass-produced product. Okay. That's probably fairly self-explanatory, but it is good to just manage expectations when we're talking about making prototypes. And you've also gone into some of the differences and limitations of prototyping in plastic and metal. What I liked was, and I'll make this point now, is that you wrote, if I do say so myself, a cracking blog post on Agillion
Well, thank you, sir.
recently, which I'll leave the link to in the show notes. And what I really enjoyed as well was at the end, you sort of made a list of some of the key limitations of prototypes, which you have definitely touched on already, some of them, and also some of the considerations that the listeners need to really have in mind when prototyping. So, shall we just go through those briefly?
Yeah, let's touch on those. I'm not going to go through these in detail, but yeah, certainly touch on them. So the key limitations, if you're reading along and listening at the same time, here we go. So
Bonus points for that.
yeah, so yeah, let us know if you are. Dimensional accuracy and surface finish. This is a big thing on prototypes, regardless of whether the method is 3D printing, CNC machining, or whatever the case may be. There's often a struggle to match the precise dimensions and the surface finish that you need to achieve in mass production. Okay, something like
Mm.
a die casting or an injection mold. We had a good discussion yesterday, I think, as one of our customers came in and he was thinking about doing a custom texture for his product. He's got some
Hmm.
sort of fairly sharp curves on the product. And we're saying, well, potentially it's not going to be good around this particular area because of the ejection issues and stuff like that. So, okay, forget it. I'm going to go with a standard texture out of the sort of the Xing book that we've got. And again, we can reference that, Adrian. But it's a standard
Hmm.
finish. But all of his prototypes to date do not have any surface finish on them at all. Okay, and he's
Yeah.
perfectly okay with that. But the rest of the team, or the rest of his team and the marketing team, have got no idea how to visualize what the surface finish is going to be like. So again, there's a key limitation on this process itself. We've touched on material properties, which is the next point on the list. And I've
Mm.
said here, CNC machine offers a close material representation of prototypes, but they lack exact mechanical properties. Now, when we're talking about exact mechanical properties, if you're looking at a high pressure die casting, and if you look at that as a cross section under a microscope versus a billet, it's going to be very, very different. Okay, they offer different mechanical properties. So again, this is a limitation. And if you're basing it upon your CNC machined representation at the development stage of what the production unit is going to be and what it can withstand, you may get false readings or a misleading result. Okay, so really important to understand that. The next point I've touched upon is production volume and cost. Now, I did mention earlier that, prototype methods like 3D printing and CNC machining are typically slower and therefore more expensive. The larger the quantities, the mass production methods, the cheaper the products will be. All right, you've got the upfront cost of the tooling and stuff like this, but, ultimately your part cost is going to be a lot less than your sort of prototype process itself, for sure. Design complexity. This is a big one, actually, and I think I've touched on this quite a bit, throughout the podcast itself with respect to, why the processes of both CNC machining or any of the other processes we talked about, you're not necessarily going to be able to achieve the complexity that you require in the final product, where you would be able to get that from a die cast, for example, or an injection mold tool. You certainly will be able to do that. Some of the injection mold tools, when you're talking about over molding and stuff like this, you're just not going to be able to achieve that very easily, through prototyping during the development stage. Again, key limitation we need to look at and consider. Post-processing. I've touched on this. A lot of the post-processing for prototypes is hand finishing. When we're talking about smoothing down the surface, you're talking about painting or spraying. You're talking about heat treatment of the 3D metal printed parts. All of this adds time. All of this adds cost. And, compared to the actual final product, it's not necessarily going to be exactly the same. So again, you need to understand that as you're moving forward in your development product and testing. A couple of other things I don't want to go on too much, but another thing is that the environmental impact. CNC machining typically generates a lot more waste material because you're machining from a complete billet of material. You get to the final part, bang, you're just using the shot weight. In other words, the weight of the component to either inject or die cast, high pressure die cast. And there's very, very little waste upon that, even down to the point where the runner system can be reused and recycled. So a lot less waste on the final production process versus CNC machining. A lot of scrap waste there.
It'll often, the waste from plastic injection molding, you've got all the little runners and things like that. They're basically little tiny plastic parts, right? And they're in a big sort of bin next to the machine. And those, they can actually be reground and used again as plastic to go into injection molding. Obviously, there's certain ways to do it. You don't just use only that. It would probably be mixed with virgin plastic. And so it's quite a circular process, actually, injection molding. It doesn't create a lot of waste.
Correct. Yes. Yeah. You don't normally just use 100% regrind. Yeah. It's the percentage is lower, but you're right. It's a lot less impactful on the environment. And the last one I want to touch on here before we go into the last two considerations is the lead time. Now, again, I've mentioned this in the last 10, 20 minutes, whatever it is. And while die casting tooling and the final production is a lot quicker because you're churning out these components per second, per tens of seconds per minute, whatever the case may be, or the cycle time. CNC machining takes time. It's a long process. And this is why it takes a lot of time. And consequently, your final bill for a single component on a prototype that's been CNC machined is generally quite high. So again, something else to look at. So if you are reading along, we're now down to the considerations. So there's a couple of considerations here that I picked up on. Just sort of share with you while you're listening now, is that
Yeah.
the ideal choice between prototypes and production methods depends on the specific needs and your priorities when you're developing your product. Now, consideration factors like required volume, the accuracy, and the material properties, your budget, and your design complexity. I'm not going to give you any examples, but, it may be the case where you're never going to hit high numbers. You're never going to require high accuracies. You're never going to, have the huge budget in order to create the injection mold tools or the die cast tools. So therefore, you may be in a situation where the quantity of products you are producing doesn't actually warrant going down that road. So therefore, you may actually, forever and a day, just have CNC machine parts. That's very viable, very viable. Okay, so that is something to look at, and that needs to be a company-wide, your company-wide review and analysis of the product, the market, your sales channels, etc. So the last consideration I want to touch on here, Adrian, is the prototypes remain crucial in the early design iteration. Okay, visual representations, I've mentioned that, and limited testing, and I've mentioned that. We need to understand what we can use these prototypes for during the development stage. And they're basically there for, one, validating your design looks good. More importantly, making sure that the product works and functions the way your specification or design has been designed to work. Okay. Now, it's a lot easier in order to have this iterative design, the changes in a prototype stage as opposed to the production stage, like I mentioned before. But however, there are limitations. I'm just reading this now. So the limitations highlight the importance of transitioning to production methods like die casting and injection molding for accurate testing and mass production. Don't just go, once you go through that hurdle with respect to, okay, development stage, done. We're now into tooling. Don't just go straight into selling your first 1,000, 2,000, million products. You need to validate the product is coming off of the tool correctly. You need to do that final round of testing to make sure that everything's perfectly okay from an assembly point of view, and everything is fit together correctly and everything like this. So you're not done testing. Once you've done your development stage, you've done validating everything, but you then need to prove that the production methodology is correct and you're producing your parts within specification. So basically, that's basically why. And if you need any help with this, we're always here to have a discussion. We've got a lot of resources on the website. We've got various different PDFs you can download, etc., etc. I know, Adrian, you've got a handle on this. But that's basically limitations of development prototypes in a nutshell.
Nice. And what a way to finish. That's true. Everybody's always free to get in touch, the listeners, if you want any help or any advice. Engineers like Paul, they can have a chat with you about your situation and give you some no strings advice. So let's wrap this up, Paul. Thanks for going through that topic. And hopefully that's shed a lot of light on what we're doing when it comes to prototyping and what our expectations should be, especially considering the two sort of key materials that we're likely to use, which are plastic and metal. Love it. We'll be back next week as normal. And to the listeners, thanks for listening. And to you, Paul, thanks for coming on. We'll get you back on soon.
Thank you. Look forward to it. Bye.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.